Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's Data Center Knowledge webinar, Designing Busway and Data Centers, sponsored by Legrand and broadcast by Informa. I'm Brandon Taylor with Data Center Knowledge, and I'll be your moderator today. We have just a few announcements before we begin. This webinar is designed to be interactive. The dock of widgets found at the bottom of your screen will allow you to learn about today's speakers, download resources, share this webinar via social media outlets, and participate in the Q&A session that takes place at the end of our presentation. The slides will advance automatically throughout the event. You may also download a copy of the slides via the resources widget. Toward the end of our webinar, we will ask you all to provide feedback via the survey widget found at the bottom of your screen. Please take a minute to fill this out before leaving us today, as your feedback will provide us with valuable information on how we can improve future events. Lastly, if you are experiencing any technical problems whatsoever, please click the help widget found at the bottom of your screen or type your issue into the Q&A area, and we will be glad to offer one-on-one assistance. Now on to the presentation, Designing Busway and Data Centers. Discussing today's topic are Chris Ocean, Product Manager of Starline, and also Nick Funyak, Field Services Program Manager at Starline. If you want to ask our speakers any questions, again, please use the Q&A area that is also on the right side of your screen. And with that, Chris, over to you.
Hi, everybody. Hopefully you're having a good day or evening so far. As far as what we're going to go over today, I'll be going over a quick intro on Busway and how it works for those who have not been exposed to it before. But then we'll go on to how AI is influencing the Busway system itself and how we're seeing it in data centers, and some of the product innovations that we have done in response to some of the AI innovations here in the last year or so. And then I'll turn it over to Nick to discuss how AI is affecting also the services side. So sit tight if you guys have any questions. As Brandon said, please put in the Q&A and we'll get to them towards the end of the presentation. So to start, I wanted just to show you what kind of predated Busway before it became more of a mainstay in the data center space. And what you're seeing on the screen is just an RPP setup from an AB. And the way that it was done previously for this type of concept is through a raised floor. And you would route, in a typical scenario, an RPP output of a breaker down through that raised floor, and then up to where it's intended to be powered to the rack. And using that raised floor, you would use cables, and it really resulted in clutter, inefficient cooling, and you definitely have a potential for wiring error there because you're a little bit less visible from where you're routing the wires from and to. So we were really seeing this take a pretty valuable data center space. And fast forward to Busway. This is using the same type of concept in that you're using an AB supplied down to racks, but instead of routing them under floor, you get rid of the raised floor, and you go from say a PDU to the Busway system itself. So in this scenario, again, you have your AB setup. You go from your PDU A and B out to the Busway system, and then the Busway spans the row of racks underneath. And to get power from the Busway to the rack, you would use just a plug-in module just above the rack. And in that way, you get a couple benefits. One is you get a local disconnect right above the rack, and it's visibly there, and it's local. So it's a lot more organized when you compare it to, say, like an RPP setup. So with Busway, you get more usable space. It's a little bit more efficient in cooling, and most definitely you get fewer wiring errors because you're not routing these long wires under floor. And then just to give you a picture of how the Busway components are comprised, this is just a slide to show you the different parts and pieces of a Busway. You start off with the in-feed down on the bottom left. That's where you bring in your power conductors to power the Busway system. That in-feed has a 1-foot section, Busway section, attached directly to it. That attaches through a splice kit that you're seeing next to it to the rest of the busway system there. So you're seeing straights, elbows, T's, and you really use these straights, elbows, and T's to customize it to virtually any application, including data centers. But typically in data centers, we're not seeing a lot of T's or elbows. They're virtually, essentially all straight runs, A, B, that you kind of saw on the last slide. So whether it's a 20, a 30, or 40-foot straight run, you're going from the power feed out to 20 or 30 feet of busway from there. And then to draw power from the busway to the load, you're using a plug-in unit pictured there on the right. And that's how you draw power from bus to whatever you're powering down underneath. In this case, for a data center, it's a server rack. And in terms of what we offer in that busway family, you're seeing on the screen our entire busway family. So it goes from 40 amp all the way up to 1250 amps. In the data center space, we're really just seeing the T5 family being used, and that's pictured in the row at the bottom. So it goes typically from 250 amp up to 1200 amp in the US. And you'll notice a couple of things with the busway. It's open channel at the bottom, and that gives the ability to add or remove circuits live or actually certified for energized insertion. Of course, you still have to follow whatever safety procedures that you have on site, but the busway is designed for live insertion, which gives the user the ability to say add a circuit after it's live and in operation. And the other thing I'll note on this is within the T5 family, you can actually use the same type of plug-in module, whether it's the 250 amp, the 800 amp, or the 1200 amp. And the reason why I mentioned that is you can help kind of future-proof your data center design, because if you end up using, say, a 250 amp for your original data center design, and then fast forward 10 years later, and you want to upgrade or even add more 250s to that data center, you can still reuse the same plugins that you originally purchased with the busway from the inception of the design. So it's very flexible in that way. And the last thing I'll talk about with respect to the busway system itself, and then we can get into more how AI is influencing the busway, is the plugins. And what you're seeing on the screen is just a handful of plugins that we've used within the data center space. But really, we have millions of SKUs of combinations for our busway plugin. We cut enclosures to length, and that allows us to customize the plugin to virtually any design. Again, what you're seeing on the screen is just a handful. We can do pin and sleeves. We can do NEMA connectors. We can do a combination of receptacle and drop cords. So you can see the variation for the plugins is virtually endless. And that really allows us, again, to customize to any design that the data center has. And so it's a great flexible way to power your server racks and your server rows. Okay, so that's just a quick exposure to how the busway works. Next, I'll be going over how AI is really shaping the busway system itself. And so what you're seeing on the screen is AI. So AI is everywhere, right? It's in your internet searches. It's in your PDF tool as AI assistants. It's everywhere on social media as well. And what does that mean to the data center and busway itself? That means it's really driving this power demand. And so the graph that you're seeing is just projected power up to 2029. And you can see this large increase from 2024 upwards to 2028. You're getting upwards of 10 gigawatts of demand increase over those years. And so the intent of the graph is to show you that AI is only increasing the amount of power that's going to be needed in data centers. And we're seeing that being deployed as well. We started off, say, around 10 years ago, where 208 volt was a very common voltage you would see in the data center. Today, we're massively deploying 415 volt and 480 volt installs. And we're even getting questions around further increasing the voltage up to 600 volts. Nothing materialized on that yet, but again, we're getting questions around, increasing the power density within a smaller space. But not only that, we're seeing optimizations on the data center floor where customers are removing their floor PDUs and using high efficiency transformers. And just to summarize, AI is really just pushing the envelope with respect to increasing the power demand within a data center. And so what we're seeing on a busway level is, again, the T5 family, if you asked me 10 years ago what our high volume products were, I would say the 250 and the 400 amp. And that's pictured there on the left. What we're seeing with AI rows and AI servers is we're seeing this huge shift to double the amount of power to power these AI racks. And so we're seeing more 800 amp, 1000 amp being used in the data center space specifically to power AI racks. And so this is kind of the higher end of the T5 family. We can go all the way up to 1200 amps, and we're getting inquiries on that as well, because AI again is pushing the envelope with respect to power. And so our top end on the open channel bus right now is 1200 amps, and you can power it up to 600 volts if you need. So really that's on the busway side. And again, whether you choose an 800 amp or a 1000 amp, you can use the same plugins between the two busway systems. And on the plug-in side, again, we're just seeing this increase in power. So for context, again, around 8 to 10 years ago, a 30 amp 2 volt or a 30 amp 415 volt circuit was very common among the data center space. For AI, we are currently deploying 60 amp 415, but that same product, or we can customize it to go up to 480 as well. But we're very commonly deploying these 60 amp circuits to AI racks, and today we're seeing the use of a multi 60 amp circuit powering an AI rack. But we're also increasing that further and providing 100 amp circuits as well to power AI racks. And really, again, this is, again, falling into that trend of increasing power. And again, these solutions that you're seeing on the screen is currently what we're deploying today and in the near future. And then a few other comments on how AI is influencing the plugins themselves. 100 amp is being deployed as we speak. And then we also have larger footprint plugins that allow for more power. I mean, we're getting inquiries upwards in the 150 kilowatt range. And we do have solutions for that you can see on the right. We can provide a 250 amp 480 volt plug, which supplies up to around 166 kilowatts. You do need a little bit of a larger footprint for that type of plugin. And I will say we are working to optimize and shrink that as well, so you can get more power in a small amount of space. But this is just to show what the capabilities are and what we can do to satisfy some of these AI requests, power requests that are coming in. And two other things worth noting here is that one on the unit on the left is a Fuse 100 amp solution. We're seeing with this kind of increasing AI power demand, we're seeing higher available fault current too at the busway. And we're currently deploying fuses to help satisfy that electrical infrastructure. So the fuses themselves have a withstand of around 200K, which is more than sufficient to handle some of these higher short circuit available faults that we're seeing at the busway. And then the middle one is interesting. It's a metered dual 60 with shunt trips installed. And really, we got requested to do this because of the shift from AI to do more liquid cooling in the data center. And the request is really driven from giving the ability for a user to shut down remotely the breakers if something were to go wrong with the liquid cooling. So this is definitely a modification that we've been fielding requests on, and we're just starting to deploy plugins with these shunts to give that ability to a customer, to give them an extra level of security if they were to do liquid cooling. All right, so that's kind of closes at least the open channel portion of it. I think the next thing I wanted to talk about was more the high power busway for NEMA. So again, our open channel busway is tops out at around 1200 amp. And so with this increasing demand, we're just seeing more requests again for higher power. And I wanted to expose the audience to this because we do have available high power bus. It's an enclosed bus. It's intended both for the gray space and the white space. So if you're seeing, your power demand, well above 1200 amp, we can still satisfy that request with our high power busway enclosed bus. So this line is all the way up to 6,000 amps and has tap offs all the way up to 1,250 amps. And the other busway related item that we're seeing AI influence to is again this shift to liquid cooling. We're seeing a shift to liquid cooling or a hybrid between liquid and air. And we're actually getting a lot of questions around, preventing damage from water because of the liquid cooling. And so we do have an S-Series busway that offers an IP54 protection. We're currently going through starting our first few deployments of it next year. And this will help future-proof busway installations if liquid cooling is a concern for your data center. The S-Series in itself is a splash-proof bus. And again, it is a IP54 rated. That 5, if you're not familiar with the IP system, stands for solid protection, so it is dust resistant. But the main intent of the IP54 bus in the data center space is the water protection, and it has a level of protection of 4, which is splash-proof. The left image that you're seeing is one of the tests that we ran with respect to the water spray, and happy to say we passed that test. Really, the only difference between the S-Series and the T5, the previous busway design that you guys just viewed, is that once you pick the location of your circuits, you install it into the busway, and we have to seal the bus after the circuit locations and the plugins are installed. And once we seal that bus, we actually get that extra level of protection against water. So again, this is something that we're seeing this shift to liquid cooling because of the increasing power densities. And if liquid cooling again is a concern, this S-Series busway is a great way to kind of mitigate that concern. All right, so next I'll show you a couple more product innovations that we've done with respect to AI. And the image that you're seeing on the screen is arc flash boundaries with respect to the arc. In the center on the right, you'll see kind of the arc source. The arc flash boundary is in gray. That varies from site to site. And the reason why I'm showing you this is that with this increasing demand of power, we're seeing a little bit more concern over adding circuits to the busway. And before I get into that, I will say and reiterate that Starline Track Busway, we are designed for live insertion. We establish ground first and last when you do install a plugin. And on top of that, we did voluntary testing, IEC 61641, which you intentionally set off an arc and see how your equipment behaves. Our equipment passed and exceeded that standard. So safe to say, busway in itself is designed for live insertion. And what we are seeing though is with this increasing power demand, some customers are shutting down the busway to add circuits. And in response, we're hearing these concerns. And so we've innovated the product in a way where you can step out of that arc flash boundary and still remotely engage the plugin. So we've modified the tap box so that it rotates, and I'll show you an image of that here shortly. But this little device that you're seeing on the bottom of the tap box allows personnel not to be in the vicinity of the arc flash zone and be outside of it, and remotely engage the the electrical conductors into the busway. How do we do that? We do that with a couple of mechanisms and modifications to the plugin itself. The first modification that we did was we have a rotating paddle head that you're seeing on the left, driven from a 1/2-inch square drive. So the image on the left shows the receptacle in that 1/2-inch square drive. That allows us to rotate the paddle to engage and disengage it from the busway. And then coupled with the two toolless hangers that are on the left and the right, the plugin can be mounted to the busway without engaging any of the electrical conductors. And what that allows us to do is once that plugin is installed into the busway, you install the remote actuator to the bottom of that plugin. You have your installer step away from the arc flash zone, and then you can use the remote to electrically engage the conductors into the busway from a safer position. And so we're offering this in both a wireless and a wired variety, and the range for both of those are 30 feet. So it's a product innovation that we're very excited about with these increasing demands in AI. If you have some concern, again, over installing the paddle, you can use this device to help reduce that risk and keep your personnel safer. And the last product here that I'm going to show you and what we're using, again, to address some of the AI influence on the busway is monitoring. We can monitor both at the busway level and at the outlet level. And the reason I'm bringing it up is for AI, we've seen some interest in wanting to monitor and trend, how much workload or current is the rack is using. And we can do that using a power meter in the plugin monitoring that particular outlet. And what that outlet monitors is current, voltage, and temperature. That's for end feeds. And then it'll give you information like power, energy, power factor, and frequency. So it'll give you all of the basic electrical characteristics that you would need. But with respect to AI and monitoring in general, it lets you load balance. It lets you set alarms for preventative maintenance. But again, kind of centering this discussion around AI, it really lets you trend current data going to the rack. And so if you connect this metering system to a building management system, you can then kind of take snippets in time and profile whatever load the plugin is powering. And you can kind of see what peaks are happening and what valleys are happening within a particular rack. And the last item I have here for you is just the product environmental profile. This is a little less related to AI, but it's something our customers have been asking for. If you have CSR metrics you need to meet, this is something that we've developed over the last year to help with CSR metrics because in some cases customers require it. And it's just an environmental profile that gives you information on manufacturing, distribution, installation, and even end of life, treatment of the project after its usable life. So these PPs are available per component and are published on our webpage. If you do have a requirement or a CSR that you need to meet using a PP, these are available on our webpage. And with that, I'm going to hand it over to Nick. He's going to talk about commissioning and the AI influence there.
Yeah, thanks, Chris. All right, guys. So like Chris was mentioning, my name's Nick Funyak. I'm Starline's Field Service Program Manager. So I oversee our business here in the US, Europe, and APAC. And, one of the things that we have seen most commonly come up with question-wise with our customers and clients and end users has always been around the AI. So Chris touched base on a lot of that stuff there. But the biggest question we have is how are we all successful together? Starline has obviously developed a busway that has been tested and proven to function and work properly, and that's step one of the process. Step two is the installation, right? So it's very keen on making sure that the installer installs the busway correctly, especially when you get down to things like the Series S busway that Chris mentioned, right? Series S is a watertight busway, water resistant. So when that gets installed, all the seals have to be set properly. So we don't stress enough around the commissioning side of stuff. So we really reach out to you guys and say, hey, from the testing and commissioning side of stuff, don't lack on that, right? So from a specification standpoint, how we can help you guys out as spec engineers and end users and clients is that, we've developed field quality control specifications for you guys to follow, right? And it's very important to do that. One, because once the busway is delivered and installed, it's important that you guys don't have the installing contractor essentially check their own work, right? It's good to have those guys there overseeing a lot of this, but I always recommend, whether it's Starline or other vendors, even your UPSs, your PDUs, always have somebody there from the manufacturer that knows their systems better than anybody else, right? So have them there for the levels of commissioning. Same thing with us here, right? I have a team of guys that stretch across the globe that'll come out and do pre-functional testing for level 3. Okay, so there's those 5 levels of commissioning. Pre-functional is typically when you start to really get into the nitty-gritty of it. And what that consists of is that's prior to busways being energized. There are a set of electrical and mechanical inspections that you want to take on those. That relates to busway open channel and obviously the bus bar, the high power bus bar as well. Both are pretty similar. And it's no different than, I always look at this as, hey, in the past, we had a lot of customers purchasing a 600 amp busway, but maybe they only loaded this up to 380 amps or 400 amps, just because they were future-proofing that design. Right now, with AI, we're seeing somebody purchasing a 800 or 1200 amp busway in day one, throwing that max capacity with density, right? And if they're going to do that, you want to make sure that you're testing that busway out to the proper specifications, right? And by doing so, we mean doing a full load test on that busway. So that's your level 4 functional performance testing. So we really stress to you guys that, hey, you want to have that in your specification to do a full load test on that busway to make sure that day one, when you guys decide to apply that large load to that you're going to have that ready to go and that busway is installed properly and it's functional. Level 5 integrated system testing is the same way. We can't stress that enough as well. You want to make sure that you have a commissioning manager on site going through that plan, that level 5 plan that either you and the commissioning agent have decided upon and agreed upon with your other vendors of, hey, this is the way we want to test our building. Because at the end of the day, right, we want to stay up and running, and not have to shut those systems down for the next 7 to 10 years or so. So it's very keen. I mean, you guys really, really want to make sure that you're testing those systems to their max capacity. So after that busway has been deployed, the next thing you guys want to look at is preventative maintenance, right? Now, from Starline's standpoint, we sell our busway as a maintenance-free design. But there are codes and regulations out there that require you guys as clients or end users to maintain that busway. They used to have recommendations. Now a lot of those recommendations became standards. And the reason being is because of the AI that's coming up, right? They know that, hey, people are going to be running their systems at max capacity. In order to be safe and maintain their systems as well too, you have to have some preventive maintenance plans in place. So always reach out to your vendors and ask about those types of plans and what they would recommend in those sets of things. Last but not least is something that I recommend specifying as well too is a contractor training. And the reason being is because you get consistency across the board, especially when you have a high-risk data center that if it drops out, right, it's either going to cost a lot or it could be catastrophic to your business. When we're going through these, we could do 5 different installs with the same type of busway and get 5 totally different installs from different contractors. All the installs might be great, but to keep a good consistency across the board and across your multiple data centers, I always recommend have your vendors come out and do a full contractor training. Verify those guys, make sure they know what they're doing with it. Even if the contractor has done this install multiple times in the past, that may have been the company that's done it, but it might not be the same guys on site. So we've been doing a lot of that with our customers and contractors, and those projects have gone really, really successful. And they've gone without a hitch. So I always recommend it. It is very important, and it really does help you guys as end users, specification engineers as well, because you guys don't have that control at that point of what contractor procurement actually decides to go with. So as a spec engineer in the past myself, I always look at it and say, okay, how can I future-proof myself and my specifications? And that's by putting that contractor training in there to make sure that although I may not be able to control what contractor we choose, I do control the type of material that we put on there, and I can control some of the services that I require with that. So that brings us to our next type of thing here that we mentioned a little briefly on is preventative maintenance. Okay, so we mentioned briefly on different types of standards. So NFPA 70B back in January of 2023 deployed their standard for electrical equipment maintenance. Now, granted, this used to be a recommendation, and when it switches over from a recommendation to a standard, it is a requirement at that point. You have some time to adopt that as a client or an end user to get your systems up and running, which we have seen quite often with retrofits. We have quite a few clients that said, hey, I'm going to continue to use my Starline busway, but I want a way to actually perform thermal scanning inside on my lugs on my end feeds. Is there anything that your company can offer? And the answer is absolutely. So from a service standpoint, my guys have gone out in the field and we have supplied a kit with an IR window that we could retrofit onto the client's end feed so that they could perform that yearly thermal scanning and stay compliant with their NFPA 70B regulations. Again, it goes back to if you're going to energize that busway and use it at max capacity, you want to make sure that you're at least checking on it as well too. One other thing that we see often that we want to make sure that it is kind of addressed is make sure that if you guys are going to do thermal scanning, whether you plan to do it on your own with your own personnel, sub that out to a third-party contractor, or use somebody from our team at Starline, right? We would love to help you out there. Always make sure that you have those guys have some type of certification. Far too often we get the call saying, hey, we're having issues with the busway. A joint is heating up. We look at that, right? We ask for those thermal reports. We start to look at the thermal imaging reports, the emissivity settings on the thermal imager. We find out that things just aren't set properly. So, over the last couple of years, I found that not a lot of guys really know what they're looking at when it comes to, thermal imaging. So always require some type of FLIR certified thermographer to come do your scanning. Or if you guys plan to do it yourself, send that guy to North Carolina and get him certified, right? Or somewhere else in your region, because it is very important. It's not as easy as just going up there, hitting it with a thermal imaging camera and saying, yes, this looks good, right? There's lots of little caveats and things like that in there that and reflective temperatures that you have to really look out for. So I recommend if you're going to do some thermal scanning, make sure that you guys have somebody on there available to do that. And that's a wrap from the service part of things. Again, key in on the commissioning side of stuff. Don't forget to specify that. That's a way to help control the project from a specification standpoint, even if that is not in your realm. So I always recommend if you're going to implement into an AI or even just non-AI type data centers, make sure that you guys are really putting that effort into the commissioning side of things so that you, one, get a good busway, two, get a great install, and three, have it for a long time without any issues.
Awesome. Thank you, Chris and Nick, for a great presentation. And before we begin with today's Q&A, please direct your attention to our webinar survey, again, available on the bottom of the presentation window. We want to thank you all in advance for filling out the feedback form. Again, your participation in this survey allows us to better serve you moving forward. And now on to the question and answer portion of our event. Again, as a reminder to participate in the Q&A, just type your question into the text box located to the right of the presentation window, or click the Q&A icon at the bottom of your screen. If we are not able to answer all of the submitted questions during today's broadcast, we will be sure to share them with our speakers, Chris and Nick, who can reply to you all offline. And so we will start, let's see, with our high priority questions. So the first question I will direct to Chris. Are there any specific tests that must be performed to the busway other than contact resistance and installation resistance?
Yeah, I think that might be more of a service-related question. Nick, you think you can field that one?
Yeah, absolutely. So from an electrical standpoint, it really depends on the region that you're in. We see a lot of ductor testing going on internationally in Europe, but domestically here in the U.S., insulation resistance test at 1,000 volts is good for checking that insulation breakdown, making sure nothing was damaged during the install, and then also just a good continuity check. From there, we do recommend doing a load test on level 4 commissioning.
Thanks, Nick. And let's see, we'll go to. And our next question is: does the remote actuator stay within the specific bus plug after the plug has been remote actuated? Can you pull off the remote actuator and use it on another plug?
Yeah, I'll take that one. So yes, you can pull the tool off. The remote actuator is intended only for the install or the removal. So for a particular data center, really you probably only need maybe one per room. It's really meant for a live install again. So it's during operation. It does not need to stay with any particular plugin. It's really just meant for removal and install of the plugins onto or from the busway.
Thanks,
Good question.
Nick. Yes, for sure. Let's see. And another question, and we'll stay with you here, Nick. Thomas wants to know, so he said Nick mentioned training in North Carolina. Are there similar training sites in California near the San Francisco Bay Area?
I'd have to look into that, Thomas, but we typically send all of our guys through Fleer. There is an online on their website. You could check that out. They do have different locations. We've sent guys to Texas for that, North Carolina, and also I believe Florida. So they do have multiple locations. I would imagine they probably have something in the California region, but it's typically level 1 thermography for it's level 1 electrical thermography scanning is what you'd be looking for there.
Awesome. And so what are the typical or industry standard bus plug cord amperages and lengths available?
We can do up to 25 feet of cord. We can do longer, but it turns into a custom, more of a custom build. And in terms of amperages, kind of alluding to one of my slides, 30 amp 3-phase was very common, until the AI boom. It's still common today, but we're seeing, more requests for like a 60 amp circuit or a 100 amp circuit. But 30, 60, those are fairly common amperages, both 3-phase that you would see in a typical data center.
Thanks, Chris. And we have another question from Thomas. He's wanting to know, does Starline or Legrand offer professional services to perform commissioning and support for new installs and ongoing maintenance?
Yeah, I'll take that one. So yes, the answer is yes, Thomas. So from my side of things, right, for my team is able to do all of the meter programming, startup, system certification, and also commissioning. We have all of our we have a whole service fleet for Starline that with trucks, trailers, load banks, all the cabling that and the manpower that we bring to site from guys that are directly hired by Starline. They work directly for us day in and day out. They are our direct employees, and we travel across the country and do all the load banking for a lot of our jobs. We've done load banking for anything from 5 to 10 busways to 200 busways. It really just depends on what you guys are looking for, and we're here to help out and make sure that testing process goes smooth. And lots of times as well too, if Starline does the testing and the commissioning, we offer extended warranties with that as well. Main reason being is because we want to show you guys that we feel very confident in this installation as well, and that we have some skin in the game, right? So we do that by offering extended warranties on your systems, so that you get to enjoy that, peace of mind there for the next couple of years, knowing that, hey, It's been installed by a contractor and tested by the manufacturer.
Great. And so our next question, gentlemen, is from Alexander. And Chris, this may be more so for you, but I'll just pose it, and then either one of you could take it. As we get into the higher amperage and density applications, is there any NEC considerations that folks should take into account?
I'd say not that I'm aware of. You're increasing, say, from 30 amp to 60 amp. It's in the same type of design and certifies to the same listing. So I haven't seen anything in the NEC that will require anything different from a 30 amp, say, to a 60 amp. You'll see a small difference in incident energy. So you still have to take whatever safety procedures that you have into account. But with respect to the NEC, I'm not aware of any changes that is required for a higher power plugin.
Okay, thanks, Chris. And I'll stay with you here. Let's see, Tony wants to know, how do you address questions related to 240.24a requiring a 6.7 max mounting height for a fused switch or a CB, and 368.17c requiring accessories for operating the disconnect switch or CB?
Yeah, I'll fill that one as well. I think that code is related to getting access to basically turning on and off the fuser, the breaker. We do offer operating sticks which allow us to toggle the breaker from the floor. So access to the breaker from the floor is feasible if you have an operating stick essentially in the data center floor, which we do have in our inventory.
Hey, Chris,
Awesome.
Can I add to that as well too? From a fuse standpoint, I know a lot of folks are just thinking, because you mentioned that earlier in your presentation, a lot of folks are thinking Class J fuses. There are fuse holders out there that we typically use as a Busman Q fuse, and that has a breaker type actuator on it that you could turn that on and off from the floor while remaining with the same fuse capabilities. It's actually a fuse disconnect that's switchable.
Yeah, good point, Nick. It does have a mechanism to turn on and off, disconnect the load as you would a breaker. So it does have that feature that allows you to toggle it on and off.
Thank you both for that. Our next question is from John. John wants to know, is the Busway rated for 100% of the nameplate rating for continuous loading?
It is. And so anything that we have, in our T5 or even in our lower amperage families, we test to full capacity at 100%. So if we had, say, an 800 amp, we tested it to 800 amps. And you can use it in the field as long as you, again, have the upstream infrastructure to allow it to climb to that amount. But to simply answer the question, the Busway system is fully rated to whatever the amperage is listed for that busway itself.
Awesome, thank you. And let's see, our next question is going to be from Brian. Brian wants to know, what is the AIC rating of the 800T at 415 volts?
We have data for 480 on our 800 amp, and we have two varieties of the 800 amp, but we mostly distribute a copper aluminum version of the Busway, and that's rated up to 65K at 480 volts.
Thanks, Nick. Let's see. And John has a follow-up question. I believe you all may have touched on this already, but John wants to know, is the Busway available in copper and aluminum bus bar options?
The Busway is available mostly in copper. So the 250 up to the 600 amp is available only in copper. When you get above that, it's available either in a copper conductor solution or a hybrid solution where we use copper and aluminum. We see more purchases more on the hybrid side, just because it's a little bit lighter and it's a little bit more cost effective. But those are your choices. It's either only copper up to 600 amps, and then above that, you get the choice of a copper aluminum or a copper copper version of the busway.
Nice. And so we have another question from Siva, and they were wanting to know, can you show the first slide that you had for power monitoring?
Yeah, let me pan to there real quick.
And Siva, if you have a follow-up to wanting to see this slide in terms of a question, definitely submit it and we can get that posed to Nick and Chris.
Yeah, I'll just lightly touch on it, and there might have been some slide advancement issues. So really, this is just to show where we can monitor on the busway. It's two locations. One is at the infeed, where it monitors basically the aggregate current of all of the loads traveling through the bus. And then we can also monitor at an outlet level as well, where you're specifically monitoring how much current and power is traveling through the outlet into the rack or the load that you're powering.
And while we're here, Nick, is the busway selectively sectionalized, like in the case of a fault in the bus itself? Could it be remotely, partially isolated as well?
So if you have a fault, the way that the busway system works, and I'll pan to another slide really quick. If you have a fault that damages a piece of the busway, you can you power down the whole bus to replace a section of the bus. So if the fault happens, say, on this particular part of this busway system, you'd power down and replace just this section, power it back up, follow your commissioning procedures, and then go about your business.
Thanks, Nick. And our next question is from David, and this is kind of a multi-part question, so I'll pose the first part of it. Do you work with edge data centers that do co-location, or are many of your data centers for single tenant or large companies only?
We do all of the above. We've done a lot of co-locations. We do a lot of enterprise data centers, and we are deploying edge data centers as well. Really, it's a matter of what kind of power requirements you have per site or per data center, and getting, again, the busway system, the right amperage to fit for that particular application. So to answer to kind of summarize, we do all of those different type of data centers with our busway system.
And so we'll drill down just a tad more with David. The follow-up question. So David is a developer and looking to build a data center about 10,000 square feet for co-location. While we do not have any tenants yet, but we do anticipate some AI customers, would you recommend your 60 amp and 40 kilowatts?
Depends on the power requirement of the rack. I mean, that's what we're seeing the most of today. If you're telling me in the future, a year from now, that's when you plan to deploy, or 6 months, it might be a different answer. So really, that's something we'd probably have to take on a case-by-case basis. But safe to say that whatever the power requirement is, we can customize the plugin to help power that particular rack or load, AI load.
Nice. And we have a follow-up question from Alexander. Is there any downside to utilizing the copper aluminum hybrid composition in the conduit? For example, is it derated or anything similar? And then also, why would you choose one over the other besides weight and cost savings?
There's no downside. They both pass UL 857. And so they're both rated, both the copper solution and the hybrid solution are both rated to, for a 1,000 amp bus, it'd be rated for a 1,000 amp bus. The benefit that you will get to using the copper aluminum system is that the short circuit is a little bit higher than the copper solution. And there's just inherent a little bit more resistance with the hybrid solution. So we get a better short circuit in that manner. But both of those systems pass UL 857 and give that same level of confidence that you can push it all the way up to whatever current rating that the busway is rated for.
And so our next question is from Thomas, and it's kind of, I guess we're kind of changing gears here a little bit with this question, but Thomas wants to know, does Starline have a list of qualified contractors who have gone through the training?
Yeah, I'll take that one. So, Thomas, it all depends on the location. We do have what we consider preferred contractors in different areas, but we're very picky when it comes to choosing the right contractor. We want to make sure that we put the right contractor in place and do that training with those guys. We do handle some installations as well. A lot of that's internationally in Europe, and my team handles all that. Where we do have a lot of really good contractors that we work with that are set up as preferred contractors for us. Here in the U.S., most of the time, my guys will go to site and train those contractors, the folks that are directly on site for that specific job. But we do have one or two here in the U.S. That we like to use for install specifically. So if there is a question around, hey, I have a job that I want to do. Do you have a preferred installer, or can we run that directly through Starline? The answer is yes, you can, and I do have those answers for those folks for you.
Thanks. Our next question is from Ashish. They would like to know, is there tap off available above 4,000 amps? And this is probably for Nick to answer.
I'll take that. This is Chris. No, we top out at 1,200 amp for the busway, so we would not have a 4,000 amp tap box available.
And Chris, does the same thing go with bus duct as well too? I imagine so, because those breakers would get pretty large.
Yeah, so bus duct right now, the highest tap off available is 1,250 amps.
Okay.
So it would not meet that 4,000 amp requirement.
Awesome, thanks, Chris. And as far as the audience goes, we have about 5 minutes or so left for questions. So definitely submit more questions if you all are wanting to dive deeper with Chris and Nick here. Let's see. And you all have probably kind of touched on this, but Caesar would like to know which points. Which points do you highlight when you compare copper cables against traditional solutions?
So I think the question centered around comparing busway to traditional copper or traditional RPP solutions, and kind of to my earlier slides, really it's the flexibility. It's an open channel bus. So comparing the two solutions, the one major point here is that with the busway, it's rated or listed to add circuits or remove circuits live. And for an RPP solution or a traditional solution, my understanding is that you have to shut down in order to add or remove a circuit, and then route that cable to wherever the location of the load is. So that's the major point there.
Great, thank you. And so let's see, and we like I said, we have just a few minutes left for questions, and this is going to be a follow-up question from David. David wants to know, if I purchase a 60 amp or 40 kilowatt, if I purchase 60 amps and 40 kilowatts, can I replace or upgrade it to higher power in the future after the system is in place?
So yes, you can, but you wouldn't retrofit the plugin itself. You would actually just purchase a new plugin and install it on the existing system. So if you purchased the plugin out of the factory on day one, and then you wanted to increase the power, you can use the same busway system that's already installed, and then order a new plug to install on the existing system if you wanted something higher power.
Thanks, Chris. And that is all the time that we have for questions today from our audience. Chris and Nick, before we transition to closing here, did either of you have any final comments for our audience today?
No, I think thanks for attending, everybody. And I'll just say, if there's any questions related to any of the product innovations that we've done or any of the slides, please submit them, and we'll take care of these offline. Thank you for attending.
Yeah, same thing, Chris. Guys, I appreciate your time, and if you have any questions from a service end of things, how to do any of your commissioning, I always recommend don't try to reinvent the wheel. We have all those processes in place and specifications in place for you. Just feel free to reach out. They're on our website. If you want to chat more about that, reach out to me as well too, and then we'll have a further conversation about it. We're here to help you.
Awesome, thanks, Nick. And that is all the time that we have for questions today, everyone. And again, we would like to thank you, Chris and Nick. Data Center Knowledge appreciates your time and expertise on today's topic. We would also like to thank our sponsor, Legrand, as well as to everyone in the audience today. We appreciate your attention and participation in our event. Within the next 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. Please feel free to invite your colleagues and peers who may have not been available to listen to the event today. This webinar is copyright 2024 by Informa. The presentation materials are owned by or copyrighted by Data Center Knowledge and Legrand, and the individual speakers today, or that you heard today, are solely responsible for their content and their opinions shared. On behalf of our guests, Legrand, Chris, and Nick, I'm Brandon Taylor. Thank you all for your time and have a great day.
Thank you, everybody.
Thank you.
Yes.